Hello friends, very good morning. Myself Dr. M.H. Annaya, and in today's video we are going to draw the development of a hexagonal pyramid which is resting on HP on its base such that two of its base edges are normal to VP. Let's see the question. A hexagonal pyramid of side of base 30 and height 60 resting on its base on HP with a base edge normal to VP. So this edge is normal to VP and this is normal to VP. And friends, here we have to place the pyramid on HP such that one of its base edges, say this edge, is normal to VP and obtain the top and front views. Friends, in the top view, since it is placed on HP on its base, you are going to get a regular hexagon with all the corners joined to O, the center of that hexagon. O represents the vertex of the solid. So here friends, we are given with the dimension of this. So each of these measures, this dimension is 30 mm and the height of the solid is given to be 60 millimeter. So this is O dash the vertex and I mark here 60 millimeter which represents the height of the solid. And friends, let us mark the corners of this hexagon as A, B, C, D, E and F. And all these are to be joined by the straight lines. O is the vertex and O1 is the center of the base. So this is the center of the base and I represent it as O1 dash. And friends, if you transfer all these points to the front view, you get here A dash, B dash, this is C dash, F dash, and this is D dash, E dash. So this is the base of the solid. This line represents the base of the solid and all these edges are visible. Hence I have drawn the front view like this. Next friends, it is cut by a vertical section plane. Friends, a vertical section plane is just like a very sharp blade which is perpendicular to HP and it is parallel to VP. A vertical plane could be inclined to VP also, but in this problem, this vertical section plane which is seen as a line in the top view is parallel to VP and cuts the pyramid while passing through the vertex. The vertex is O. In the top view, you have this O here. And there is a section plane which is vertical and that is represented by SS and that is passing through the vertex of the solid. Now friends, after marking this section plane which is parallel to VP, let me show the portion that is retained or that is retained for the purpose of drawing the development of the solid. So this part of the solid is now retained for the purpose of drawing the development. This part and even this is to be added. And friends, this part is thrown out. The portion below this is thrown out. And here friends, we are going to retain the upper part above the section plane. The bottom part is removed. And friends, we have to next obtain the true length of all the edges, particularly the slant edge, because the base edges are always true in size in the top view. And here if you observe, the slant edges O dash A dash, O dash B dash, all these slant edges, among them, none of the slant edges are parallel to VP. In other words, none of these slant edges give the true length of the slant edge because we need to have the true measurement or true length of all the edges to obtain the development. Hence friends, what I do, here I have this line that is the slant edge OD. Say, I will take this slant edge OD, keeping O as center, OD as radius, I draw an arc. Say it will meet this line here. From there, I write a vertical line upwards and I join that to O dash. And what happens when you join to O dash, D dash here? This becomes a D1 dash, and this line will give you true length. That is O dash up to here will give you TL. TL represents the true length. So using this true length as the length of the slant edges, I draw the development of this hexagonal pyramid, assuming it is not cut by any section plane. So very obviously, there are going to be 6 faces, that is triangular faces in the development. And now friends, you can have the development started from any one of these, either OB, OD or OC, because they are totally removed. Say I am starting from this OC. So this is the true length. So I am going to draw an arc taking O as center, true length as radius. I have drawn an arc. And this is also the true length here. And on this arc, I have stepped off 1, 2, 3, 4, 5 and 6 edges. And all these measure 30 mm each. 30, 30, etc. And as I said before, since this lower part is removed, you can start the development from OB or OC or OD. Say I am starting from C. So this is one slant edge C, then comes D, E, then you have got F, then A, B and C. Friends, the starting line and the ending line should have the same marking, because when you unfold, bring them together, these two should join. So here friends, let us see where all the section plane is cutting the solid. And if you observe closely the top view, the edge AB of the solid is cut here. That is exactly at the center AB at a distance of 15 mm from here. It is cut. Then the edge D is cut here. And again, the section plane is passing through the vertex O. So we have got one point here, the vertex, one on the base edge, and one more point on the other base edge. So in the development, we are going to get only 3 points. Which are they? So friends, here, if you observe this, AB is cut exactly in the center. Where is AB? AB is here. So I just mark a point there exactly in the center. Similarly, DE exactly in the center, we have got a point. And the third point is O, the vertex. So only 3 points you have got. One for the vertex and 2 points for the base edges. And friends, if you closely observe this figure, out of the total 6 triangles we have got here, see here, this is 1, 2, 2.5, 3. 3 triangles are removed. So in the remaining part here, we have to have only 3 triangles. That is 1, 2, half plus half. So totally there should be 3 triangles in the development. Which are they? One is OAF, other is OFE. Let us see them. One is OA, OA and F. OAF. So I am going to join that. O to A, O to F. And this is one such triangle. So this is one triangle. Then next friends, we have got OEF. Where is OEF? OEF. So you have to join this by dark line. This is the second triangle. So this is one, this is second, and half of. So friends, here we have to join O to the point on the base. O to the point. So from here to here, if I join, so this is half triangle you get here. This is to be shown by visible line. Similarly, this has to be joined here. And this part is to be shown by line. So friends, what is not existing in the development is are the edges OB, OC, OD are not there. So OB, OC, OD, OB. So it is not existing, show by thin line. OC, it is not existing, show this by thin line. And then OD, OB, OC, OD is also not existing. So only this part from O to this point, this base here till here is remaining. And to make it more clear, let me number them as 1, 2, 3. 1 for the vertex, I can show here passing through O. 2 for AB, say this is point 2 and this is point 3. So if you observe this closely, friends, in the development, you should have only 3 triangles. So which are those triangles? One is OAF, the second one is OEF, and then these 2 triangles, 1A to this point AB, which is represented by 2. 1, 2, and this is point 3. So only you should have half triangle, half triangle. This is half triangle and this is half triangle, and these are 2 full triangles. So whatever the solution we have got, that is the development of this part P. If we call this part as P, this figure will give you the development of P. Development of P. Friends, this is how we obtain the development of the lateral surface of a hexagonal pyramid which is resting on HP on its base with one of the base edges normal to VP. And this is cut by a vertical section plane SS which is passing through O, the vertex of the solid. And because of the symmetry in cutting the solid, you are going to have 3 triangles in the development. 1, 2. This is half exactly, this is half. So you are going to have only 3 triangles in the development. Friends, I hope the presentation was interesting. Please go through the complete video. Do not skip any part of it in between. And if you like this video, do share this video with all your friends without fail. I thank you very much for watching my YouTube video. Have a wonderful day.